Have you ever wondered what happens when an aircraft carrier runs out of fuel in the middle of the ocean? Most people's first instinct is to sail back to port and refuel slowly, but that's simply not realistic. These massive ships weigh tens of thousands of tons, and a round trip would waste an enormous amount of time. In reality, aircraft carriers refuel in a way that's very similar to aerial refueling for airplanes. So here's the question. How do two massive ships, both rocking on the open sea, connect a fuel line without snapping it? The answer lies in one key principle: sailing side by side. The supply ship and the warship move in parallel at exactly the same speed, typically about 28 kilometers per hour, with a distance of around 40 to 60 meters between them. You can think of it like two heavy trucks driving side by side on a highway. If one speeds up or slows down even slightly, the connecting line could snap instantly. Once their speeds are synchronized, the crew on the supply ship fires a line across using a line-throwing gun. This thin rope acts as a guideline, which is then used to pull over thicker cables step by step until finally the fuel hose is brought into position. The most critical component is the central steel cable system. It's not just there for show, it serves two major purposes. First, it supports the heavy fuel hose. Second, it stabilizes the system against waves and wind. Even in rough seas approaching level 8, it must keep everything steady so the hose stays aligned and fuel can continue flowing. Once the connection is secured, the pumps start and fuel begins flowing rapidly into the warship. Some systems can transfer up to 4,000 liters per minute, almost like pouring water. But the faster it goes, the higher the risk. Operators must constantly monitor positioning systems and carefully control cable tension. A single large wave can suddenly change that tension. At best, it disconnects the hose. At worst, it can snap the expensive fuel line entirely. And the consequences aren't just financial, it could also lead to serious safety hazards.